Today's lesson is 4-3 multiplying and dividing monomials. So we're going to go back to that foldable that we glued in the other day. Okay, so you're going to flip back to it. It should be dry now and stuck in there. So we're going to be filling in the middle section today. Okay, so really big on this middle section, you're going to write monomials. Hold on a second and I'll write it on here so you can see how to spell it. It is M-O-N O-M-I-A-L-S. Monomials. So fill that in. Okay, so you're just writing on your paper. Okay, then you're going to flip it open and we're going to write a definition again on this middle section. So we are writing the word monomial. I have the definition over here on the board. It says monomial is a number, a variable, or a product of numbers and or variables. I know that sounds confusing, but it'll make a little more sense once we go over it. So write this down also. A to the m power times a to the n power equals a to the m plus n power. So if we have the same base, we can add our exponents. So then I did an example of actual numbers. 2 to the 4th power times 2 to the 3rd power would mean you do 2 to the 4 plus 3 power, which equals 2 to the 7th power. Okay, so let me hold this out. Pause the video so y'all can write that down. Now, looking at example 1, it says find each product expressed using positive exponents. So on this first one, since it's 4 to the 3rd power times 4 to the 5th power, since they are the same base of 4, same number, and they're being multiplied, we can take it and say, okay, well that's 4, and then add your exponents, 3 plus 5. 3 plus 5 is 8, so that would be 4 to the 8th power. Okay, and then if they wanted to solve it, us to actually solve the answer, we could. So then on B, I have 6 times 6 to the negative 4th power. Again, I'm multiplying with the same number, so I add my exponents. When there isn't anything out here, if you remember, how many 6's do you see there? 1, so it would be an exponent of 1. So we would have 6 and then 1 plus negative 4, which comes out to negative 3, 6 to the negative 3rd power. Well, it said using positive exponents. So I then take that negative 3 and put it under 1. 1 over 6 to the positive 3rd power. So you're going to try numbers 1 and 2, or excuse me, 1a and 1b. Make sure you write it using a positive exponent. So pause the video, try those, and then I'll go over them with you. On example 1a and 1b, we have 5 to the 2nd power times 5 to the 3rd power. So since it's the same base being multiplied, we add our exponents. So it's 5 to the 5th power. If we'd solve that, 5 to the 5th power, that's a big number, 3,125. I can't remember if it told you to solve it or not, but at least 5 to the 5th power is the main part of that. And yes, I know I'm wearing the same clothes as like your last 3 videos because I love you guys so much. I am up here on a Saturday recording all these lessons for y'all. So anyways, 1b. We have 12 to the 3rd power times 12 to the negative 2nd. Since it's the same base being multiplied, we can add our exponents. 3 plus negative 2 basically comes out to 3 minus 2, which is 1. 12 to the 1 just equals 12. All right, so on example 2, we're still doing the same thing, but now instead of numbers, we have letters or variables. So we're still finding the product, which means the answer to a multiplication problem, using positive exponents. So A says b to the 2nd power times b to the 2nd power. Since we're multiplying with the same base, we can add our exponents. So it's just b, and then to the exponent, we'll say 2 plus 2, which is b to the 4th power. So then when we have t to the negative 5th power times t to the 3rd power, I keep the base and I have negative 5 plus 3. We have to use our addition rules for adding with a negative and a positive number. So it comes out to negative 2. T to the negative 2 power, negative 2nd power. We have to write that with a positive exponent. So we have to put it under 1 on a fraction. So 1 over t to the 2nd power. So I want you to try that with some variables now. You're only going to do 2a and 2d. I circled them for you. So you'll pause the video and try those, and then we'll look at example 3.
In 2a, we have y to the 6th power times y to the 3rd power. So multiplying with the same base, you add your exponents. 6 plus 3 is 9. We don't know what y is, so it is just y to the 9th power. Then we skip to 2d, multiplying with the same base, so you add your exponents. Negative 6 plus 2 is negative 4. So then we could leave it like that, but if they wanted a positive exponent, it's 1 over x to the 4th power. Don't forget making it positive.
On example 3, it says find each product expressed using positive exponents. So we're doing the same thing, but they've taken it a step further, and now we have numbers out front, which are called our coefficients. Now, we can do this still because it's still x and x. The x is what's being raised to the exponent. So this is 2x to the 3rd power times 8x to the 4th power. So they rewrote it. Since it's all being multiplied, we can put our coefficients together and then put our x's together so we can combine our exponents. So out front, we have 2 times 8, which is 16. Over here, I can rewrite that as x to the 3 plus 4. Because they're being multiplied, we can add our exponents. So 3 plus 4 is 7. So I have 2 times 8 times x to the 7th power. 2 times 8 is 16. So all of that together is 16x to the 7th power. So then on B, we have the same thing, same type of problem. Negative 3n to the negative 9th power times 2n to the 8th power. Since it's still the n's, and they're the same, that are being raised to an exponent, we can multiply these coefficients, negative 3 and 2. So over here we have n to the negative 9th power times n to the 8th power. So negative 9 plus 8 is negative 1. So we get down here, 3 times 2 times n to the negative 1st power. Well, negative 3 times 2 is negative 6. So we have negative 6 n to the negative 1. But if you remember, you can't have a negative exponent. They want your final answer to be with a positive exponent. So you would put that under 1. Well, it's negative 6 times 1, so you keep the negative 6 on top. It's the same thing as saying times 1 over. Well, n to the 1st power is just n, so we don't have to write that. Well, when it's being multiplied by like this, you can just combine that by putting this whole number on top. So negative 6 over n. That's where they got that. So I know this is a step further, so it may take a little longer, but I want you to pause the video and try 3B and 3C on your own, and then we'll go over it.
Okay, so we're taking it a step further. On 3b, we have 6b to the negative 4th power times 2b to the 2nd power. Since these are the same, we can multiply these other numbers. You could almost take 6 times 2 out front if you want. Then that leaves b to the negative 4 times b to the 2nd. 6 times 2 is 12. Then, since we have this, we can add those exponents. Negative 4 plus 2 is negative 2. So we have 12b to the negative 2nd power. Writing it with the positive exponent would be 12 over b to the 2nd power. Now looking at C. 6x to the 3rd power times negative 3x to the 5th power. Since they're both x's, we can multiply these coefficients, these front numbers. 6 times negative 3 is negative 18. Then we can add those exponents. 3 plus 5 is 8, so negative 18x to the 8th power.
Okay, last thing we're going to look at, example 4, or last example we'll look at. Now we're looking at the quotient, which means the answer to a division problem. So they went ahead and wrote them as fractions, but it's dividing. So on A, we have 8 to the 5th power over, or divided by, 8 to the 3rd power. Okay, so on this, when they are dividing, we subtract our exponents. Just like when we when we're multiplying, we add them. So we keep that base of 8, and we have 5 minus 3. Well, 5 minus 3 is 2, so that is 8 to the 2nd power. Okay? Okay, so on B, we have c to the 7th power over c to the 2nd power. So that means c to the 7 minus 2, which is 5. C to the 5th power. On problem C, we have 2 to the negative 2nd power over 2 to the 2nd power. So that would be 2, and then we have negative 2, the top, minus the bottom, which is minus 2. So negative 2 minus 2 more is negative 4. So 2 to the negative 4th power. We can't have that. We have to write it with a positive exponent. So 1 over 2 to the positive 4th power. And then problem D, d to the 5th power over d to the negative 2nd. So dividing, we subtract our exponent. So it's 5 minus, and we have a negative 2 on bottom. So 5 minus a negative 2, if you remember, that just becomes 5 plus 2, which is 7, d to the 7th power. So I want you to try 4B and 4C, and we'll go over them together.
So now when we're dividing, you subtract your exponents. Multiplying, you add. Dividing, you subtract. So since they're the same number, we can subtract our exponents. So it's b to the 7 minus 6th power, which is b to the 1st power, and we don't have to write that, so all that, and our answer comes out to b. All right, on 4C. So I have 4 to the 5 minus the negative 2. That doesn't drop. It's still minus whatever that is. Well, our subtraction rules, you change the sign, add a line. So it's 5 plus 2. So this one comes out 4 to the 7th power.